Hello, Mr. Area, are you alright?
Yes.
Okay, so remember, we talked about how to calculate the sum between 1 to n, right? 1 plus 2 plus 3 plus 4 plus till 10. What's the answer? So n, the sum.
55.
Oh, sum. Okay, so it's equals to I equals 1 to n. Yeah, this is the sum. Yeah, and then what? I, right? Yeah. Okay, so this is a mathematics symbol. How do you calculate? Why is it 55? Is it 55?
Yeah.
How do you calculate 55?
1 and 10 is 11.
Yeah. And then
2 and 9.
11. Yeah. So how many pairs with it?
5.
5 pairs of it. Right? 5 pairs. So it's 55. Write down. Okay. So in general, if it's 1 plus 2 plus 3 plus n, what's the answer? What's the equation for that? Do you still remember? It's okay. You don't remember.
No, I think it's.
What's this? What's the if fn is the sum of these? So what's fn? What's it equal? Do you still remember? How do you generalize this? You know this is 1 plus 10 times 5 pairs. How do you get the 5?
Okay, so I think it's n plus the first one divided by 2.
Times n divided by 2. Okay? Yeah?
Uh,
First item and last item. How many items are then divided by 2? Okay? So it doesn't have to start with 1, right? So look, if it starts with if 5 plus 6 plus 7 plus here n, what's the answer? This one, yeah? You want to come in?
okay.
Okay.
Got Pokemon.
Okay. So look, it's first item plus last item times how many items are there, right? So n plus 5 and times how many items are there? Yeah, divided by 2, yeah?
Yes.
Yeah, okay. So what's this? n plus 5 times how many items? n minus 5 plus 1 divided by 2, okay? So in general, this is any integer sum, right? I was talking 1 plus 2 plus 3, any numbers, yeah? 1 plus 2 plus 3 plus 2 plus n is, the answer is the first item plus the last item times how many items are left divided by 2, okay?
Yes.
Another easy way. Eric, look.
Yes.
1 plus 2 plus 3 plus 4.
Forever.
Okay, so
Equals
if
10.
look, 1 plus 2 plus 3 plus 4 equals how many? I can do this way.
10.
Look, how about if I fill this? Look, I fill this with the cross array. Look, this is the magic. I fill it. And I fill one more. Okay, so what do you notice?
It's just
It's the equal.
yeah.
So these circles are equal to the, how many circles are equal how many cross, right? And how many of them are together? This is n. This is n. This is n. This is n plus 1, right? Because we fill it 1, right? So it's n times n plus 1 divided by 2. Got it? Yeah? Ryan, do you understand it?
Yeah.
Eric, do you understand it?
Yeah.
This is how we prove. We prove what? 1 plus 2 plus 3 plus till n. The sum is this. Okay, so now today's question. Okay, let's coming up to today's question. Alright. So let's build the stairs. If we have n circles, okay, maybe coins, okay? We have n coins, yeah? These are coins, yeah? Okay? These are coins. We have n coins. And we want to put the n coins, build the stairs of coins, like the first one, first row 1 coin, second 2 coins, third 3 coins, and so on. So if there are 10 coins, this is 10 coins. You need to tell me we can build 4, okay, 4 stairs. But if I only have 9, right? Alright, look, I only have 9. So you need to tell me I can only build 3 for stairs. Got it? Make sense? How about 15? How many stairs can we build? 15.
5.
5. And how about 14? 4. Yeah, you got that, yeah? Well done. Good job. Good job. Okay, so what's your so how we calculate it? This is basically the other way, yeah?
You just go down and just find the
You understand the problem? We're talking about.
steps.
So for previously we know the end, we can calculate the sum. That's easy, right?
Yes.
But now we know the
Yes,
sum. We
yes.
want to go back.
You just start from 1 and then do how many?
And then you want to accumulate until you reach that, right?
Yeah.
That's one solution, yeah? Look, that's one solution. That's one solution, yeah, well done. That's called simulation, yeah? We simulate the process, how we build it, yeah? So look, I'm just write the pseudocode, yeah? Okay, look. Let's say the answer at the beginning we have 0, right? And we have n, right? We have n. So let's say we have okay, maybe this is the rows. Rows equals 0, okay? Right? Yeah? And then I, let's say I equals the first one. So while I, this is the coins we are, maybe we name it as current, okay? Current row equals 1, okay? 1 is here. So look, why we have the coins, current row, okay, current row, why we have coins, why n is bigger or equal than what, than the current row, right? Now we need to do what, rows, we can build this row plus equals 1, right? And then we need to subtract n equals current, right? Now the current equals, the next row is what, plus equals 1, right? Look, Eric, look, is it? And then return rows, right? This is the answer we're looking for. Yeah, okay, let's see. This is simulation, yeah? We want to return the number of rows we can build, right? And this is the current number of current coins we have to put in the current row, yeah? The first one is first row is first coin, 1 coin. When we have coins, and when we have enough coins for current row, then we can complete one more row, right? And then we subtract the coins from the row, from the total coins, right? And now what's the next? How many coins for the next row is current plus equal 1, and then we return the rows. So this is the simulation. Okay, so if n is very big, yeah, this is getting. The time complexity is getting what? How do you calculate?
Bigger.
Yeah, it's getting bigger. No, not really. Look, how many times? How many iterations do you think you will reach? You will become n will become less than the current. How many iterations? Actually, we can prove it, right? Look, we can prove it. Look. We know, right? We know n times n plus 1, right? Divided by 2, right? It needs to be smaller or equals than actually let's not call it n. Let's call it the row. Okay, let's call it r. Okay, and result r rows. This is the number of coins if we can build r stairs. That should be less or equal than n, right? Right? So what's this? Okay, let's write this. What's this? If we times multiply 2 by 2 sides, so r times r plus 1 small or equal to n, right? Got it? Yeah, from here I multiply 2 both sides, and the equation still stands. Okay. What's this? Remember, Eric. We talk about this a plus b squared. Can you tell me what's this? A squared plus b squared plus
C.
There's no c. Come on. How many a? Look, Eric.
Yes.
2 times ab. Okay. Yeah. Got it. This is remember it. This is very important. Yeah. Got it.
Yeah.
Okay. So now look. R times this is what? R squared plus r, right? Plus what? Plus what? If I plus 2 if I plus 4, if I add a quarter here, right? And I need to subtract a quarter on the right hand side, right? I need to plus a quarter at the other side, right? Yes? Okay, so what's this? R plus 2 a quarter, a half square. Look, R square plus a quarter plus 2 times this, right? Is smaller or equal to n plus 4, a quarter, 1 over 4. Okay, so if we get the square root of both sides, if we get the square root of both sides, look, can you, yeah, this is how we deduce it. So look, R plus a quarter, half, smaller or equal, because R is positive, right? If R is positive, so that's why we can square root on both sides, right? So that's 2n plus a quarter, and then I move this to the right hand side, subtract half. Okay, so R is smaller or equal than this, and we want the integer part. We want the floor. Look, this symbol. Look, what's this? What's this?
Floor.
Floor. You know the floor function?
Yeah, like if it's you just round it.
Floor 3.5 is what?
Closest.
Floor 3.5.
4.
Floor, come on. 3.5 is here. What's the floor?
It is 3.
3. What's the ceiling?
4.
Yes. So ceiling is this. Yeah. This is ceiling. Look, it's quite visually. Yeah. This is floor. This is ceiling. Yeah. Floor is the largest integer, less than counted number. Let's see. Ceiling is the smallest number, which is bigger than 3.5. Yeah. Yeah. Okay. So we want this. So R is this. So the clump complexity of that simulation is this. O. Right? Okay? So
Nothing.
no. If you do the simulation, right? Like remember the previous one, why we have enough coins for the current row, yeah? We subtract the coins from the current from the total coins, we increment the coins for the next row, and we increment the number of rows we can build, right? The time complexity is this. But if I implement this function, I can just return 2 times n plus a quarter square root minus half. What's the time complexity if I just calculate this bit? If I calculate this, what's the time complexity? What's the time complexity? What's the time complexity? What? What's the time complexity if I want? We want to calculate it. So I give you a hint. If it's a mathematical expression, it's usually, I would say it's usually O1. Okay, usually O1. If we don't consider, if you don't consider the time complexity to calculate the square root, right? So it's O1. Okay. So yes, this is the most perfect, but we can also binary search it. Yeah. You see the binary search. Okay, I'm going to write the binary search, and you tell me. Yeah. You know the binary search. What's binary search? Yeah, look. Look, this is n1 to n, and I want to find the number between it. And if I can have a function to tell me that if it's bigger or smaller, so every time I can narrow down the search space by half, right? It's like, okay, so how do you explain the binary search, Eric? Like, any of you can tell me what's binary search?
Level by level, baby.
Binary search, you know the level by
Half
level.
it.
Half it, yeah.
I thought you said
Yeah, so look, 1 to 100. I have a number between 1 to 100. You guess.
Yeah?
Yeah, can you guess?
50, 25.
No. Okay, you guess. I tell you if it's bigger or not. So I have a number in mind.
Yes.
Can you guess?
50.
It's bigger than the number I thought.
75.
It's bigger than the number I thought. Okay, it's bigger.
100 million.
So look, you said 50. I said 50 is more than the number I saw. So what?
25.
Okay, it's smaller than the number I saw.
0. Then I'll go for 38.
Yeah. Okay, you know the game, yeah. So every time you cut in half, right? So your search space is narrowed out. Every time you cut in half. So the time complexity of binary search is usually log n, right? We will talk about this in the very first few lessons. Okay, so now let's say look, we want to build the coin, yeah. Look at this. Let's say the first one and the n row, right? But we are not sure how many rows we can build, right? The R row, okay? But they are totally n coins, right? But look, if I'm guessing, I can build 3 rows. So I know how many coins I need to build the 3 rows, right? Yeah? Because we just know, right? N times n plus 1 divided by 2. This is the number of coins we need to build the n rows, right? Yeah? So depending on this, we can halven the search space, okay? Yeah? Define, okay, build stairs of coins. I know we have n coins, right? So the beginning, left, let's say left equal left to right, left. The minimum we can build is 1 row, right? Yeah? Yeah? If n is positive than 1, yeah? If n is bigger than 0, okay? If it's 0, then obviously we can't build anything, right? If n is bigger than 1, bigger or equal than 1, the minimum we can build is 1 row, right? The maximum is what? R rows. We can put it n rows, right? Yeah? Okay, so why left is smaller than equal than R, right? Okay? What's the middle? How do we cut the middle? If left is, look Eric. What's the middle? Left. Right, and anybody? Left or right, what's the middle?
Left plus right divided by 2.
Okay, divided by 2. You can do this, or you can shift it by 1, yeah? Look, shift it by 1. This is also okay, right? Look, shift it. You don't need to put a bracket because the plus takes priority over the shifting. So it's the same as this, okay? So shift it. And then now, how many coins we need? How many coins we need to build the n rows? How many coins we need to build n rows? How many coins we need to build n rows? Huh? How many coins we need to build n rows? N times n plus 1 divided by 2. This is the formula, yeah? We just talked about, right? Okay? If k equals n, so what does it mean? We can build the n rows, right? This is the coins we need, and this is the coins we have.
Yeah.
Then return what? Return what? What's the row? Mid n, okay? If k is smaller than n, we don't have enough coins. So we don't have enough coins, so we need to increment the row or we need to decrement the row. Come on. If we don't have enough coins,
Plus.
we need to increment. So not plus. So we need to do what? Mid. The left equals what?
Mid.
Plus 1, right?
Yeah.
As we have enough coins, we need to reduce that.
Right.
Right equals what?
Minus 1.
Well done. And then we need to return what? This is a big tricky. Return what? Return L minus 1, right? Because it's already minus 1. Or return R. Yeah, return R or return left minus 1, alright? Yeah? Left minus 1. Look, because L eventually will be n plus 1. We need to subtract 1. R is okay, right? Got it?
Yes.
R is n. What's the time complexity of this one? Come on. Oh, what? Oh, what? Come on, it's very. What did I just say about binary search?
1.
Huh?
N.
What? What's the binary search? Always halving it. What's the time complexity?
Logan.
Oh, okay, come on. So we talk about 3 solutions, okay? Let's review a little bit. The first one is simulation, yeah?
Yes.
We start to simulate by putting the first coins on the first row, second row, third row, and so on. That time complexity is that formula, right? Because the formula, yeah? O or what? Square root 2n plus, I come from a quarter, yeah? Minus half, right? Something like that, yeah? This is the time. The second solution is mathematics, yeah? We just calculate this formula, which is O1, right? Yeah?
Yeah.
The third solution, binary search, which is O log n, right? Make sense?
Yeah.
Make sense? Got it? Make sense? Yeah? What's the formula of calculating the first n integer? I equals 1 to n. Sum of I. What's this? What's this? What's the sum of this? What's the sum of this? N integer. Ryan, Eric? N times
2.
n times what?
N.
What's 1 plus 2 plus 3 plus 4 plus till n? What's the sum? Ryan, Eric, come on. You know it before. What's the sum? What's the sum? Come on, what's the sum?
N plus M.
Plus 1 divided by 2. Come on, it's here. That's the way. We know the n rows and how many coins? It's the same. I'm just using different. Okay? Got it?
No, I said and
N.
said it isn't.
N plus n times plus 1 times n divided by 2. Okay?
Yeah.
Okay, good job. Okay, good job today. Good job today. Bye bye.